Hello everyone, good morning. Dear authors and invited guests, welcome to Technical Session 7A. Myself Deepika Jain, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2024, Jaipur, India. The ninth edition of the conference has been held in a hybrid mode. The physical event was held in Jaipur, and the virtual event is being held through Zoom, which was yesterday and today. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter would be getting 8 minutes for their presentation and 2 minutes for any question and answers. On 7 minutes, I will be raising a gentle reminder. There is a request for the participants to, stay with us till the end of the session, till the closing remarks. And if you have any query, you can directly message in the chat box to me. We'll just start in 5 minutes. Starting the meeting, I would like to introduce to our session chair, Dr. Ramesh Chandra Punia. He is a professor at the Department of Computer Science, Christ University, India. He has completed his postdoctoral fellowship from the Cyber Physical Systems Laboratory, Department of ICT and Natural Sciences, Norwegian University of Science and Technology at Norway. His research interests include sustainable technologies, cyber physical systems, path planning and collision avoidance in artificial intelligence, and intelligent algorithms for autonomous systems. I welcome to the session, sir.
Yeah, thank you, ma'am.
Okay, so we can start with our first presentation.
Yeah, please proceed.
Shri Sridhar is here.
Yeah, please proceed.
Yes. You are presenting a paper on a survey on dynamic routing and blockchain integration in autonomous vehicle networks, enhancing safety and efficiency. Right, ma'am? Are you ready with the
Yes,
presentation? You can start sharing your screen, please.
Oh, is my screen visible, ma'am?
Yes, your screen is visible and you're audible as well, ma'am. You can start.
Yeah, thank you. So this is Nakshatra. I'm here to present my paper on survey on dynamic routing and blockchain integration in autonomous vehicle, enhancing safety and efficiency. So autonomous vehicles are revolutionizing transportation with enhanced safety and efficiency. So this paper presents the development of real-time dynamic route optimization algorithms for autonomous vehicles. So in case of any traffic or adverse weather conditions, the vehicle must be able to reroute to the most optimized path. So additionally, blockchain technology enhances data security, which is critical for safe operation in connected environments. Blockchain is used for communication between vehicles. So this paper explores recent developments in dynamic routing optimization for self-driving cars. So coming to method, we have three main areas: routing, blockchain usage, and communication among vehicles. So we will see the technologies and algorithm utilized here. So in initial route planning, we use algorithms like Dijkstra's to select the optimal route from point A to point B, considering traffic and road conditions to minimize travel time and cost. So they take already available data and come up with an efficient route. Blockchain detection, it employs LiDAR technology, which uses a 3D map using laser beams, achieving 90% accuracy in detecting obstacles. Camera sensors are cost-efficient way to improve self-driving car safety. Path routing, it adjusts routes dynamically based on real-time data about obstacles. So vehicle adjusts its route using the information from its surroundings based on the latest available data. So the smart contracts define the path routing rules for the autonomous vehicles, which are then recorded on the blockchain. So blockchain technology, it ensures secure data sharing among vehicles through cryptographic methods. Using smart contracts, we define path routing rules and manage vehicle activities, exchanging efficiency and security in route selection, and store it in blockchain. Consensus mechanism, it ensures agreement among the nodes on routing rules, which help in maintaining system integrity by excluding compromised nodes. So this periodically will evaluate nodes trust and explains that removing malicious nodes can increase the accuracy. So blockchain can exchange battery details and history of vehicles and fact digital currencies which are ensured. So in B2B communication, we use telematic devices which enable message exchange between vehicles to enhance road safety and traffic efficiency. It uses wireless technologies like dedicated short-range communication or cellular vehicle to everything to exchange real-time data between vehicles while enabling vehicle to predict and prevent collisions, optimizing traffic flow and enhance driving safety. So by using VANET, we can turn every participating vehicle into a wireless route or a node. Secure communication framework, it proposes a secure V2V communication scheme based on 5G technology, incorporating verification tools to protect against potential attacks. Coming to traffic management in autonomous vehicles, in reservation-based junction control, vehicles will reserve their turn to pass through the intersection using first-come, first-served protocol. So this reduces vehicle delays compared to the traditional traffic signals. In evaluating policy intervention, it examines fixed policies to manage how AVs move in traffic, focusing on improved traffic flow. Autono VI system, it plans collision-free routes while considering vehicle dynamics, which improves how smoothly AVs can adapt to different scenarios. Managing vehicle a mathematical model and an algorithm to adjust AV route dynamically. It will help to avoid conflicts between vehicle on shared roads. And swarm intelligence, it relies on vehicle to vehicle and vehicle to infrastructure communication. It improves traffic flow, which is verified with tools like Sumo and Omnet. In decentralized collaborative algorithms, vehicles collaborate to find the fastest path based on traffic changes over time. So it reduces travel time by 40% and improves road usage by 45%. IoT ILTMF method, it focuses on logistics for AVs, considering energy usage, optimizing route, ensures efficient delivery and resource use. Enhanced depth first search framework, it accounts for factors like travel time, distance, cost, and driver preference to find personalized routes. In vehicle to infrastructure based route generation, we use sensors and recursive algorithms to plan routes for AVs connected to infrastructure. It will create optimal routes dynamically based on the sensor data available. In centralized dynamic solution, it will predict traffic and it will adjust vehicle routes dynamically. It helps to improve travel speeds and reduce traffic congestion. In ant colony optimization for ride sharing, it minimizes cost while ensuring effective route planning for multiple users. In end-to-end driving with dueling queue network, it uses reinforcement learning method that combines camera images and vehicle movement data. It trains the system to drive better than human drivers by making smarter decisions. DCCS SF for highway driving, it is a decision maker designed to improve safety and efficiency during highway driving. It performs better traditional reinforcement learning approaches. Real-time road surface evaluation, it uses deep neural network to monitor road conditions in real time, while multi-agent reinforcement learning, it is a method where multiple vehicles learn to work together to optimize traffic flow and improve coordination. So this method is proven efficient with simulators like Sumo. Model predictive control with neural network. It combines a predictive control framework with neural networks to better estimate vehicle states, especially under certain uncertain or changing conditions. It outperforms traditional predictive control methods. Human-like decision-making with CNN, it uses convolution neural network to mimic human driving behavior and also helps to reduce accidents by making decisions similar to how humans would in a real-world situation. So coming to safety, we have enhanced A-star algorithm, which improves the classic A-star pathfinding
Dear
algorithm
presenter,
by
you have
factoring
2 minutes left.
yeah, okay.
Yeah.
So in enhanced A-star algorithm, it is a pathfinding algorithm by factoring the distance to obstacles. So control algorithm, it uses predictive planning to stabilize the vehicle. It improves how well the vehicle flows, uh, follows its path and reduces the severity of crashes in simulations. So safety framework with ISO, it proposes a safety framework based on the industry standards to ensure autonomous system and are resilient to failures, which offers a detailed analysis of system strengths and limitations. Model predictive control for emergency, it focuses on reducing crash severity through better motion planning, and fact graph for safety security. It uses graph-based approach to connect safety failures with potential security threats. And a risk assessment measure, it introduces a method to calculate the probability for safety violations. It provides a numerical way to access crash risk and improve safety measures. So to conclude, challenges like scalability, real-time adaptability, and privacy concerns, it remains. So we need to focus on solutions that not only address these challenges, but also to make autonomous routing more reliable and efficient. Yeah, thank you, sir.
Thank you for your presentation, Nakshatra. Sir, any questions?
Yeah. Yes. Can you let me how to utilize your blockchain in your vehicular network?
Yes, sir. So when vehicles communicate, we use telematic devices to communicate among vehicles within the short range of area. So the details, if suppose there is an accident happens, so the data which is in around a particular limitation of area where the vehicle get the information, that information will be passed to the vehicles within the certain range limit. So those data are being stored in blockchain so that a third person shouldn't tamper the data and it shouldn't mislead the vehicle, sir.
Okay. Okay. Thank you. Yes. Over to you, ma'am.
Thank you, sir.
Okay, thank you, sir. Thank you, ma'am. Thank you.
Thank you.
Thank you. So moving to the next presentation. Uh, the next presenter is Rakshan Khan Kulkarni, who would be presenting a paper on detection of DDoS attack using machine learning algorithms. So are you ready, sir?
Hello.
Yes, sir.
Yes, ma'am. Good morning. My name is Rakshan,
Yeah, you can
and
start
today,
sharing your screen, sir. Hello?
yeah, just a moment.
Yeah.
Is it visible?
Yes, sir.
Good morning, everyone. My name is Rakshan, and today I will be presenting on detection of DOS attack using machine learning algorithms. So this is the outline of my presentation. Introduction. The distributed denial of service (DDoS) attack is a malicious attempt to disrupt the normal traffic of a targeted server, service, or a network by overwhelming it with a flood of internet traffic. These attackers exploit botnet to generate excessive traffic, disrupting services, causing financial loss, and eroding customer trust. The research aims to leverage machine learning techniques to detect DOS attacks more effectively and mitigate their impact. And as we have done the literature survey, we can see that DOS detection techniques have evolved significantly. Initial methods rely on signature-based and rule-based systems. However, modern approaches use machine learning and deep learning techniques to improve accuracy and adaptability. Several studies have inspired this work, focusing on applying supervised and unsupervised models to network traffic data. This is the block diagram of our project. The process begins with data collection from sources like Kaggle. Next, the data undergoes pre-processing to normalize values and handle missing data. Features such as packet count, byte count, source, and destination IP during this are extracted. Finally, machine learning algorithms are applied for detection and classification. Model architecture. The data preparation. The dataset consists of 23 features, including source and destination IP, that is a packet count, byte count, and the other data. Dataset splitting is done in the way that is 70% of the data was used for training and the 30% is used for testing. We applied k-fold cross-validation for robust evaluation. Next. Next is the model evaluation. Scripts for model evaluation. We use standard metrics such as accuracy, precision, recall, and the F1 score. The performance of each model was compared and the results were visualized. Random forest consistently achieved the highest accuracy across all protocols, making it the most effective method for detecting DOS attack in our study. This is the result. For TCP, UDP, ICMP protocols, random forest uh, outperformed better than the other models in the terms of accuracy and FN score. Ensemble techniques such as combining random forest with AdaBoost showed marginal improvements in detection accuracy. These findings underscore the potential of machine learning in enhancing network security. These are the confusion matrix for UDP, TCP, and ICMP. The conclusion in this is the study demonstrates the effectiveness of machine learning in detecting of DOS attacks. Among the models tested, random forest emerged as the most reliable method. Balanced dataset and proper pre-processing were critical to achieving these techniques. Moving forward, integrating advanced architectures like CCN and RNN could further enhance detection accuracy. The future scope for this model would be enhancing detection accuracy by incorporating data from IoT and cloud services, developing real-time detection methods using advanced architectures like RNN, combining machine learning with network segment to contain and mitigate attacks more effectively, exploring techniques to identify and prevent zero-day attacks. These are the references from which. Thank you.
Thank you. Thank you, Rakshan. Sir, any questions?
Yeah. Hello.
Yes,
Yes.
sir.
Yeah. Actually, on the DDoS, a lot of work has been done. So, what the
Yes, sir.
novelty in your research actually? Because nowadays everywhere we are using the machine learning. So what the novelty? Hello, am I audible?
Yes, sir, you're audible.
Hello?
Yeah.
Yes, sir. So the novelty in this is the model what we are using, it is an ensemble model, sir, which is currently we are optimizing using ADA boost. That is a after the detection of all the this thing, the TCMP, ICMP, after these models, there is a comprehensive feature set that is of 23 detailed features. We are taking the multi-model protocol of DOS attack, and we are balancing all the performance across the protocols, applying a hyperparameter tuning.
But you did only classification, no?
Yes, sir, this is the classification, but this is not mitigating of the DOS attacks, sir. Only the classification. In
So
the
it's
future scope, yes, sir, we can do the mitigation also of these attacks.
okay. Okay, I think it will be do, then it will be good for the readers. Okay, so
Yes,
try
sir.
to
Yes,
include
sir.
incorporate it. Okay, thank you. Go ahead, madam.
Thank
Thank
you.
you. Thank you, sir. Do we have Ruby or Rahul here? Whose paper title is Analyzing the Application of Robotic Process Automation Across Retail Processes and Evaluate an Implementation Framework. Anyone here from this paper? Okay, so we can move to the other presentation. We have Venkata Ganesh with us, who would be presenting a paper on digitizing handwritten characters from images. Sir, are you ready?
Yes, ma'am. Yes, ma'am. I'm ready.
You can share your screen, sir.
Okay. I hope the screen is visible.
Yeah, I can see your screen and you're audible as well. So you can start.
Okay, first of all, a very good morning to one and all. This is Ganesh from Chaitanya Bharat Institute of Technology. Now I'm going to present the project which is digitizing handwritten characters from images. You see the agenda, these are the agendas which you are going to know. First of all, let me walk through this problem statement, which we are developing a system using this YOLO object detection, which is multiple object detection for the handwritten characters, mainly 0 to 9, as well as we are using the symbols from images and getting these symbols into a real-time environment, like digitizing them and performing into an Excel sheet. Mainly these focuses in the getting of a mark sheet which were trained and also tested in diverse data sets. Coming to the abstract, basically we are using the YOLO versions, like upcoming version. I mean, now it is V9 and followed by V8, V7, and V6 and V5. Using this YOLO architecture, as you see, the present generation is going, everything is digitizing. We are mainly focusing on the digitizing the numbers as well as the symbols, so that we'll get these into fine-tuned models and get into a digitizing world. Coming to the introduction, hence the reason why we use YOLO is, hence it is a model which is based on the multiple detection. Our page consists, I mean, if you take a data set of multiple numbers and also symbols, it will collect all the numbers and all the numbers as well as the symbols, take into a Excel sheet, performing some of the activities on it and get into the result, like addition, subtraction, division. Okay, if you see the proposed system, first we collect the data and also labeling the data according to the perfect class. For example, the 0 is labeled as 1, 0, and 1 is labeled as 1. Similarly, plus, minus, division, as we see the operation operators. And next we train with the each model like V9, V8, V7, V6, and V5. Based on the models which we train, we will validate the upcoming classes. Like we have classified 0, 1 like that, right? Based on that, we will validate and also test these models and After getting all the results from this, we'll have a model comparison, which is giving the more accuracy, right? And the dataset which we are using are MNIC dataset, symbol dataset, as well as the ultra YOLO versions, which are 9876. And for this, we have used the label AMG, which is present in the package of YOLO for the classification of the plus, minus, as well as the numbers. Yes, here is the short code of the implementation. And we are using the Ultralytics YOLO versions for the data collection as well as the model training. If you see here, it is the label AMG which I was spoke before. Like this is the package where we use for the classification of plus, minus, as well as the symbols as well as the numbers from 0 to 9, so that the each will be stored in separate, like for the validation as well as the testing purpose. Coming to the results, these are the confusion matrix which we got from using the YOLO V9C version. And speaking about the confusion matrix, if you see here, the FN's confusion matrix says that the prediction of 1 and 0 refers to the how accuracy the model is trained, and how the performance of the model which we have trained. And this is the F1 score of the V9C model. If you see, it is giving us 0.86207 based on the parameters. And here at the right side of the presentation, you can see the classification which we have done, like minus 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, divide equation and everything. And this mainly F1 score deals with the how accuracy as well as the precision the model goes. And these are the detected numbers. And if you see here, we have the all training and differences metrics precisions, which we get like there is a loss, like while we are going with the cleaning data, we have some of the missing values, and also we train them and processing them through the model. We got these results. Okay, coming to V8S version, which is small, if you say S means this is a confusion matrix, which is normalized one, and these are the detected numbers as well as the symbols. And this is V8 version M, which is medium, which is having a comparatively, yes, M is the one which is now leading based on the parameters what we take, like in the epochs also. It has been giving the best prediction. If you see the F1 score, it is 0.99 accuracy. And these are the detected one. Okay, coming to V7, there is only, the one which we worked is V7 version only. Like in that, there are no specific configurations like S and M and C. It is only V7. And it is giving an F1 score of 0.8807. Comparatively, it is less when we compare with the V8 version M. And these are the detected one. Hence, you can see there are multiple objects if you consider every number as an object. This is mainly the use case of the YOLO, and which gives as a fast detection. And this is the least version. Like if you take YOLO V5, yes, which was at the starting, it was introduced. Here's the confusion matrix. And also, if you see the fund score, it is 0.69 FC, which is if you see the graph, the one which is detecting is not up to the mark. As well as if you see the graph also, there are outliers in this graph also, which says that the number is overlapping with other. So this model gives that the better requirement is there in the version. And these are the detected one. This is the tested on V5. And this is V5M, which is upgradation of this V5S, if you see. And it is giving more F1 score, which is resulting in 0.86572. And this is the train and testing boxes which you have done on the V5M. Finally, overall, the result comparison of each version is presented here. If you see the loss as well as the precision, the most accurate one was, if you see the YOLO V8M version, which is giving the metrics recall at 0.99338, which is the most accurate which we have followed.
Dear presenter, you have 2 minutes. Yeah, we are concluding. No problem.
Okay. Concluding this presentation, this project mainly deal with the automation of the handwritten characters with the best accuracy, so that the data which we have extracted dealing with the numbers as well as the symbols combinedly get the numbers into it extracts into a Excel sheet, which we have the numbers as well as symbols, so that the overall calculation of the sum will be detected. The main motto of this project is, in our college, we are having a manual entry of the marks. For that, we are making this automation so that the marks will be automatically scanned through the mark sheet data set and also calculated. And so we are working these YOLO versions. And these are the references which we have taken. Mainly the reference was fourth one, like deals about the handwritten recognition using machine learning algorithm. Thank you.
Thank you. Thank you, Ganesh. Sir, any questions?
Yeah. Yes. How to validate your accuracy or Appman score and precision and others parameters for your confidence level? How you can say
Ah,
that accuracy is right?
yes, yes. As you can see, I have presented here the F1 score, right? If you see
Mhm.
the F1 score, this mainly deals with the how much the prediction, like how
Mm,
much, for example, the value is it, the
mm,
detection, if the object detector is accurate, like it is
mm,
detecting worst case scenario, if you take the 80 is not written properly. But
mm,
the F1 score, if you compare, if it is
mm,
giving properly, then we can say that the model is trained well.
mm. Okay. Thank you. Go ahead, madam.
Okay, sir. Thank you. Thank you, Ganesh.
Thank you.
So we have our next presenter with us, Nishit Joshi, who would be presenting a paper on exploring the feasibility of a transfer-based approach in the era of deep learning. Sir?
Yeah, okay. So let me share my screen.
Yes, please.
Is the screen visible?
Yeah.
Okay. So in this paper, we have looked at how, like, there are problems with the corpus-based machine translation systems. Like, one of the problems is that if we have proper name entities, we have person names or location names or organization names, then the current state of the art techniques, they fail to translate them properly. So, if we have certain rule based approaches, certain transfer based approaches that have been time tested, and if we can intermingle them with the current state of the art, then it would definitely improve the accuracy of the system. So, this was the basis of working on this paper. And I'm Nishit Joshi. I'm from Banastali Vidyapeeth. My co-authors are Palak Arora, Bharti Nathani. They both are from Banastali Vidyapeeth, and Chandra Prakash Dadlani. He is from Government College Ajmer. So, this is the basic outline of the paper where we'll be talking about introduction, literature review, evaluate, methodology, evaluation, and conclusion. For an introduction, machine translation are essentially computer algorithms which try to translate certain text from one language, one natural language, to another natural language. There have been considerable efforts in developing such systems, and it dates back to 1950s during the Cold War when the Russian ciphers were being translated into English and were given to US Department of Defense for various different purposes. Over the years, machine translation system has evolved from basic rule-based, transfer-based approaches to example-based approach to statistical learning approach. We called it statistical machine learning, and to current deep learning systems, which we call neural machine translation systems. These are the basic literature reviews. I would not go into them because we have a scarcity of time. So I would directly come to the methodology. So in this approach, what we did was in order to train a machine translation system, we needed to had a parallel corpus, a corpus which would have the source sentences and the target equivalents for them. For our study, we chose Sindhi as the language, because Sindhi is a very under-resourced language. There are not much resources available on net for Sindhi as far as Indian context is concerned. There are a lot of there is a lot of content available for Sindhi, which is written Persian-Arabic, which is basic lingua franca of Sindh, Pakistan. But for Devanagari script, there are not much resources available. So we started working on Sindhi from the Devanagari context. And in this study, we used English corpus and we translated the text corpus into Sindhi. So we had a parallel corpus available with us. Now, while translating this, we also use certain off-the-shelf tools like Stenza, which looked at the name entities and the pause tags of English equivalent sentences, and then we created a system, a submodule, which would translate these name entities, the person name, location names, or organization names into Sindhi. Like, for example, if I say Indian Institute of Technology. So in Indian Institute of Technology, for Hindi or Sindhi, it would be written as Bharatiya Pradyogiki Sansthan. We don't transliterate it. We don't just change the script and keeps the sentence as it is. We don't write Indian Institute of Technology in Hindi. We write it as Bharatiya Pradyogiki Sansthan. So this was the problem. This is where the machine translation system, the neural machine translation systems, they generally fail. So we collected these organization names and location names, and we created a system, a knowledge base, which converted these English name entities into Sindhi name entities. Now, since our approach was not exhaustive, so there were possibilities where the system might not be able to identify a correct name entity. It would not be able to translate the correct name entity. So, in those cases, what we did was we also had a transliteration system which would convert the script of the source language into the target language. So this is how the entire corpus was translated, was transformed in from English to somewhat augmented corpus, which had Sindhi, Hindi, English, and Sindhi equivalents from the source side. And this is the basic working of the system, where we take an input, we extracted the name entities using our by LSTM tagger, and then we segregated those name entities. If they were location or organization names, we had a knowledge base where it was found. If it was found, then it was translated, otherwise it was transliterated. Next thing what we did was we created a byte pair encoding. Now byte pair encoding is a subword. It's a below it disintegrates the entire word into smaller segments. This is a tried and tested method in neural machine translation systems because it improves the accuracy of the system in because at times if we don't have certain words that are seen in the data, in the training data, then also it tries to translate those words into the target site. This problem is known as out of vocabulary words. Next, we trained the model, and here what we did was we trained the model from English to Sindhi, and we trained one more model from Sindhi to English. So we had two models that were trained using the pre-processing approach that we had. For English side, we used the Stenza, Postagger, and the NER system. For the Sindhi side, when we had Sindhi as a source language, we used our own Postagger that we had developed in a lab. It was a bidirectional LSTM model, and then we extracted the name entities from it. So, for example, if I have a sentence like a Sindhi sentence like Nishit Joshi Nai Delhi je Indira Gandhi International Airport kha Jaipur jo safar kare riyo ahe. So here, the very first thing was done was we extracted the system extracted the name entities. So Nishit Joshi was identified as person. Nai Delhi was identified as location. Jaipur as location. Indira Gandhi International Airport as organization. So these were the name entities that were extracted. Now Nishit Joshi are person names, and no matter how many person names we might take in our knowledge base, it would never be exhaustive. So we generally skipped that. So Nishit Joshi and Jaipur, these were the name entities that was not found in our knowledge base. So they were simply transliterated into Nishit Joshi in English and Jaipur in English. The rest of the name entities like Nai Delhi,
Dear presenter, you have 2 minutes.
okay, and International Delhi, Indira Gandhi International, they were found and they were translated correspondingly. So this is the basic working of our system where some sentence, source-side sentence is available. So we tokenized it, we provided sentence normalization to it, we did pause tagging, we extracted the name entities, and then name entities were translated through our submodule. And then this intermediate output was then filtered and then was given to the neural machine translation systems, the framework that is available, and then certain post processing was done, and finally we got the translations out of it. For evaluation, we used three popular evaluation matrices that are part of any of the machine translation evaluation studies. These were Blue, that was developed in 2002 by an IBM group, Pempney and his group at IBM. And then there was the CHRF and CHRF++. There are two matrices which are recently used, and they have become very popular in machine translation evaluation framework. And we also did human evaluation adequacy and fluency scores. So for Sindhi English, we had 21.6. I'm sorry, it is Hindi written over here. For Sindhi English, it was 21.6 and 47.3 and 48.7. So generally, a blue score above 18 is considered as that the system is usable. So for Sindhi English and English Sindhi, both on both the sides, the system was doing well. As a conclusion, in this paper, we used a bidirectional Sindhi English machine translation system. We trained the system using a basic submodule which had a transfer based approach. And for both the directions, the system performed relatively well, and it had good correlations with human evaluation. These are the references. Thank you. I'm open for questions.
Thank you, Nishit. Thank you so much. Sir, any questions?
Yeah. Yeah, you did good job, but what the impact of as a global level you did for work with the Sindhi language and local language, especially in the Jaipur region. But what the global level impact of your research?
See, Sindhi as per se is dying. Like the current generation, the new generation, the kids, the Gen Z, they don't speak Sindhi at home. The
Uh-huh.
reason being that their parents don't speak Sindhi. So,
But this is only for local region, not the international level. So what?
like even the Google is trying to develop us English to Sindhi or a Sindhi machine translation system, but then their Sindhi is in Persian-Arabic. So they are putting in efforts for developing a Sindhi machine translation system for Persian-Arabic, and there have been no efforts done for Sindhi Devanagari. So this is what we are trying to do.
Mm. Okay. Okay. Thank you. Good job.
Thank you.
Yes, ma'am.
Thank
Go
you,
ahead.
sir. Thank you. So we have our next presenter with us, who would be presenting a paper on intelligent network management with classification algorithms. Sumita?
Yes, hello.
Yeah. Yes, ma'am. You can share your screen.
Yeah, ma'am. Okay. Good morning, one and all. My name is Sumita Agaddin.
Please
And
share your screen first so
yeah,
that I
yeah,
can
I'm sure. Yes, ma'am. Yes, you're able to see the screen.
Yes, ma'am. You can start.
Okay. Good morning, one and all. My name is Sumita Agaddin, and the topic of today's. Am I audible? Hello.
Yes, ma'am. You're audible. You can please start.
Okay, ma'am. Yeah. Today's conference is Intelligent Network Management with Classification Model. And my students are Prabhav, Prajwal, and one of my colleague, that is Sunita Budhihar. And the content of today's presentation is like introduction to intelligent network management and types and role of this, then coming to application methodologies, benefits of a classification, challenges, and then coming to a future trends, conclusion, and references. So coming to our network management. So what does this mean by network management? It's a process of monitoring and controlling a network resources for an performance purpose and also for an security. And coming to the word intelligent, like how it is used in the network management, where with the help of machine learning, artificial intelligence technique that we are doing. Then coming to a goal. So here we are enhancing the network efficiency, reducing the downtime, and we are improving the performance. Yes, types of classification algorithm here, as we know, supervised learning and unsupervised learning. So in coming to supervised learning, it is predefined data set and where we come across regression and classification. And our paper is focused on supervised learning. And types of classification algorithm, here we are making use of random forest and naive Bayes algorithm. And role of classifications algorithm, as here you can see that in network management, traffic classification, anomaly detection, and fault prediction. And coming to an anomaly detection is because here whatever the data sets that might be like not in the according to the range. So that's the reason here where we are making use of this kind of detection in case in the data set if there is a such kind of data. Then coming to application here, that is traffic classification, anomaly detection. Coming to a methodology, to have a clear view of this methodology, here we are going with a flow chart. Starting the data acquisition takes place and pre-processing. Before splitting to a data set, we go under into a three process, that is normalization, cleaning a data, then traffic generate. So after having these all things, splitting of a data takes place for training and testing. And once the training is done, here, as I told, like we are making use of an algorithm. And after making training and testing, what here we are doing, we are classifying the particular data set. And what are the benefits of the classification in the network management is, first thing is atomization, improved network efficiency, security, and the cost reduction. Challenges here we are coming across is data quality, scalability, adaptability, and model interoperability. And a future trends is that AI and deep learning, here what happens means incorporating the deep learning algorithm and even more accurate and efficient classification will be taking place, and real-time decision making will be possible, and self-healing network. Conclusion, as we can see that classification algorithm is playing an essential tool in the modern intelligent network management. And these are the references that we took.
Okay, ma'am. Thank you. Sir, any questions?
Yeah. Madam, actually, you applied the classification. So you
Yes,
have
sir.
calculate the precision recall, another metric.
Yeah. Yes, sir.
And how to assure that these algorithms or the particular algorithm is perfectly working for the traffic management, network management.
Yes, sir. Like here we took, as you can see that, like here what we did here for an YouTube, like I can say the data sets that here we have been taken.
What
For
data
that,
set you have taken?
like here we are like taken like YouTube, Microsoft, Amazon. So those all like how the network will be managed. So like we took, so.
What was the size of your data set?
I guess it is more than 1000 GB.
More than?
More than 1000 GB, sir. Yeah.
How many features you have used? And which features are more correlated?
I guess nearly we have taken 21 attributes, sir.
Which one is more correlated?
The one with the attribute which is having an like more viewed stuff.
No, more correlated. Correlations you have generated with the heat map? Correlations you have generated or not? Hello? Am I audible?
Sir? Yes, sir. Am I audible to you?
Yes.
Yes, sir.
Yes, let me. You generate the correlation or not in 21 attributes.
Yeah, sir. Done, sir. Then only like we are able to get like precision recall, F1 score, and all right.
So which one is more correlated and why?
So like one with the more viewed data set, like based on the ratio of an formula of an precision.
No, no, no. I'm talking about that attributes, not precision, recall, and other factors of the accuracy. How to calculate F1? F1 score. Hello? I think so. You need to focus on such type of the parameters and try to incorporate the novelty for the readers. Okay. Thank you. Yes, ma'am. Over
Thank
to
you,
you.
sir. Thank you, ma'am. Thank you. Thank you. We have our next presenter with us, Devi Shri Nadar, who would be presenting a paper on leveraging Flutter and Dart for educational tools, a case study of Agnes quiz. Ma'am?
Hello,
Yes, ma'am.
am I
You can
audible?
Yes, you're audible. And please, can you please share your screen?
Yeah.
Yes, ma'am. Yes, ma'am. Your screen is visible and you're audible as well. We can start.
Yes, thank you. So our paper title is Leveraging Flutter and Dart for Educational Tools, a case study of Agnel's quiz. And I'm honored to present on behalf of my team from Father Agnel College, which is in Vashi. This project was a part of our second year journey where we delved into Flutter and Dart to develop a personalized educational tool for engineering students. So our project focuses on a mobile app for engineering education built using Flutter and Dart. This app ensures cross-platform compatibility. With Flutter's hot reload feature, we achieve rapid development. The app enhances self-assessment and learning experiences, making education more accessible for students. So education is evolving with technology. Apps like our Agnes quiz combine technology with traditional teaching um, to enhance the overall learning experience. They offer we offer personalized, accessible, and interactive methods in engineering education, where engaging students and simplifying complex concepts is often a challenge. Mobile apps provide interactive tools that promote active and deeper understanding. So this is our related work. In our study, we explored Flutter and Dart's capabilities in educational tools. And this studies mainly underpin the reliability and innovation potential of Flutter, Firebase, and Firestore in building robust educational tools like Agnes Quiz. So our proposed system was, so the problem statement is, since traditional learning lack so many engagement and interactivity, we have planned on developing this quiz app to improve the engagement and interactivity. And our objective was to develop dynamic and interactive learning environment using personalization experiences. And our technical challenge was the app should mainly work on both iOS and Android device. So it should be
Hello,
cross-platform compatible. Hello?
hello, Devishri.
Yes.
Yes, sorry for the interruption, but your slides are not moving.
Yes, yes. Yes. Now you can move. Next one.
Yeah.
You are on the proposed system.
Yes.
Yeah. Okay.
It
Can
is.
you do? Can you do it on the full screen?
Yeah, just
Presentation. Presentation mode.
is it visible?
But it's not as a presentation mode.
Ma'am, it's visible. You can, if you can do it full screen, it would be great, or you can continue with this as well.
Yeah, I guess full screen is not working. It's
Okay. Okay. Go ahead. Go ahead.
No issues.
Yeah. So our solution was to use Flutter and Dart to develop a unified cross-platform quiz application. And our core functionality was using Firebase for user authentication and database management, where in user authentication, the user can register, login, and profile management can be done using Firebase authentication. And the Firebase Firestore uses no SQL database. So we have used that feature of that in Firebase to store and retrieve the quiz questions. And next, this is our reference technical architecture, where we have the mobile is connected, like in mobile, the front end will be shown, and plugins, we have used so many plugins. And then the front end is connected to database, and it is also connected to Ilias. So the Ilias in this diagram acts as middleware like system that connects the backend and database. So in our application, API connect the Flutter front end to the backend. The backend in turn connects with the database to retrieve and store the data. This is our application flow. So here the user can enter the credentials and enter into the app. So here you can see these 4 subjects: ML, BDA, BLOG, and NLP. These are the STEM 7 engineering subjects of computer science students according to Mumbai University. So we have since our guide, she teaches final year students. So she said us to take the subjects and prepare. We can study this. Then as soon as they select any subject, question will be displayed. If the answer is right, the score will get increased. If it is wrong, right answer will be displayed for 1 second. And then at the end, they can see the result, and the result will also get reported to the teacher. This is our implementation. Here you can see this is the user login page, and this is our main page. Here they can select any subject.
Presenter, ma'am, you have 2 minutes.
Yeah, okay. Then this is our quiz page. Then this is our result page. Then as soon as the result is displayed, it will also get the teacher can also see here in this admin dashboard, and the teacher can also add questions or delete questions they want of particular subject, and they can also view result of all the users. So as I said, our guide, she has tested this app among 50 engineering students of our college itself, and this was the result. As you can see, the overall satisfaction here was 92%. So, and this is to further highlight the innovation behind Agnes quiz. We conducted a comparative analysis with similar platforms, and Agnes quiz stands out for high interactivity, real-time feedback, and personalized learning targeted at engineering students. And that's it. As for conclusion, we have developed the Agnes quiz using Agnes quiz app using Flutter and Dart and integrated Firebase. And then this app is for mainly engineering students of SEM 7. And as for future work, adaptive learning and expanding the subject coverage, that will be the focus. Thank you.
Hello. Yeah. Good job
Hello.
actually, and good development of the application. Can
Yeah.
you let me what backend you have used and what the size of that and how to configure all these things?
Yeah, backend, for database, we have used Firebase, as I
Mm.
have said, Firebase Firestore, and like there will be it uses NoSQL. Like there are collections in collections. There are NLP, BDA, separate collections, and it has respective questions. And
How
what
many
was
how many
request?
users at a time can access or can give the QH?
I guess it I do not know that. We have developed it in developers mode only, and then
Because
our teacher
because
has only tested it among engineering
yeah,
students.
I
So,
understand your concern. My concern is that suppose n number of
mhm.
the students, like in the thousands or more than thousands or lakhs students are sitting with your applications. So what the optimizations you did actually? What the
Oh,
it's exactly is working or not, or only the specific number of students is working?
yes, only specific number of students. We have only 120 students in our college in computer department, so we have only kept that in mind, not so much scalability.
Okay. 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 Good job. You can think about that in future work. Maybe you can utilize the cloud and how to do the things. Okay.
Yeah.
I
Okay,
possibly
sir. Thank you.
okay. Good.
Thank you, sir.
Okay.
Thank
Good.
you, sir. Thank you, ma'am. Thank you. Okay, so we'll move on further. We have our next presenter with us, Mohammad Shamin Hassan, who would be presenting a paper on randomized algorithm for online case server problem on a line. Yes, sir.
Hello, ma'am. Can you hear me?
Yes, sir, I can hear you. Can you please share your screen?
Yeah. Is it visible?
Yes, sir. It's visible.
Hello, everyone. I am Mohammad Shamim Hassan. I'm going to present our paper, Randomized Algorithm for Online Case Server Problem on a Line. This project was collaborated with Bangladesh University of Engineering and Technology and University of Arizona. Let's introduce what is online case server problem is. There are total case servers in a metric space, and the request appears one after another, that is in online manner, and we need to move one of the servers to satisfy the request. Specifically, online case server problem on a line, the servers and the request lie on a same line. And there is a famous algorithm known as double coverage algorithm on a line, which was introduced by Krobeck et al. In 1991. There are two kinds of requests, outside request and inside request. When the request appears at the leftmost or the rightmost on a line, we call it outside request. And when the request appears at any point between the servers, we call it inside request. So in this research, our objective is to use randomization technique to fool the adversary by using randomized decisions. And we worked against adaptive online adversary, and our goal is to minimize the total distance traveled by the servers. The CSABA and LODA developed a randomized algorithm for online case server problem, and they proved that their algorithm is order n-log n competitive, and they worked against an oblivious adversary. The difference between their research and our research is that we work against adaptive online adversary, which is stronger than the oblivious one, because the oblivious adversary knows the randomized the description of the algorithm but doesn't know the randomized decisions. On the other hand, the adaptive online adversary also knows the randomized decisions, past randomized decisions of the algorithm. So before developing our algorithm, we make some assumptions. At first, we take in evenly spaced points on a line, and the length of the line is twice k plus 1, where k is the number of servers. And initially, the servers occupy k distinct point on the line, and two servers doesn't locate at the same point. And at every step, some points in the line will not be occupied by the algorithm, and the adversary will always place the next request in one of the unoccupied points. So we call our algorithm randomized server on a line, or RSL. At first, we assign one Boolean variable to each of the server, and initially all the Boolean variables or bits are 0. The behavior of our algorithm depends on the distance between the servers and the request, the states of the corresponding bits, and RSL is independent of the past events. So when we face an outside request, the RSL moves the nearest server to satisfy this request, and it keeps the corresponding bit unchanged. But but for an inside request, the RSL employs a probabilistic selection rule like this and move the server S alpha with probability P alpha. If we want to define the rule, for any inside request, there are two adjacent servers, left one and right one, which is SL and SR. And S alpha here denotes any server, either SL or SR, and S beta will be the other adjacent server of S alpha, and B alpha and B beta are the corresponding bits of these two servers. Besides, D of S alpha and D of S beta are the distance between the servers to the request, and capital B is the XOR operation of the corresponding bits. Okay, then we prove that we prove our first theorem, which is the RSL algorithm is epsilon k competitive against any adaptive online adversary when k is constrained between 1 to 99 exclusive and epsilon is 0.99. So if we see how we proved the algorithm, at first we employ a potential function to measure the variation between the configurations of our algorithm and adversary. Specifically, if we see the equation here, the potential function is actually the difference between the distance of the RSL servers and the distance of the adjacent servers. Then we examine the expected changes of the potential function del phi. Next, we compare the costs of incurred by our algorithm RSL and the adversary. For this, we define a random variable, which is xi, and if we see here, it includes three terms: the cost incurred by RSL, the cost incurred by adversary, and the expected changes of the potential function. And finally, we analyze how the actions of the two algorithms, our algorithms and adversary, affect the cumulative sum of the random variable. For this purpose, we used randomized analysis and show that the contribution of this adversary and RSL's actions to expected changes of the random variable is never positive when epsilon is 0.99 and k is 1 to 99. That means that the RSL algorithm is epsilon k competitive against any adaptive online adversary, and this theorem is proved. Then we verify the significance of Boolean variables in developing RSL. So we prove another theorem, which states that without using Boolean variables, the RSL algorithm will not be 0.99 or epsilon k competitive against any adaptive online adversary. And for time shortage, we didn't put the detailed proof here, but our paper holds everything related to the proof. In summary, we actually have two major contributions. At first, our results show the power of randomization since the RSL surpasses the famous double coverage algorithm for a specific constraint where n equal to 2s k plus 1 and k is 1 to 99. And secondly, we introduce Boolean variables for the first time and showcase that the significance of this to enhance the randomization and the competitive ratio. Still, there are some interesting open problems like the probability bounds and the constant can be improved, and the algorithm, the RSL algorithm can be generalized to any arbitrary metric space rather than only for online for the line. So that was my our research. Thank you all. If you have any question, feel free to ask.
Yeah,
Thank you.
Mohammed.
Thank you.
Yeah, Mohammed. Actually, how to calculate your complexity, like is time complexity and other complexities? What you think about that? You have calculated or not?
Actually, we didn't calculate the complexity.
So without this,
Time
how we
complexity.
can say that our proposed algorithm is perfect?
Actually, we followed the I mean extended proof technique. Like if you say the random variable.
Yeah, that is okay, but complexity should be checked now. Okay, no problem. I think so. You in your future work, you should be included in your research. Okay. Thank you, Mohammed. Yes, madam, over to you.
Yes, sir. Thank you, sir. Thank you, Mohammed. Thank you.
Thank you.
Okay, so we have come to the end of our session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. And I, on behalf of the whole team, thank you for the support during the 9th version of this conference and for all the previous 8 versions as well. I hope to see you in the 10th version of this conference in 2025. All the presenters would be getting their certificates through email within 2 working days. And the papers have already forwarded as Springer board, and the publication will be live within 6 months. Kindly cooperate with the team. I also thank our session chair, Ramesh Chandra Punia. Thank you, sir. Thank you for chairing the
Welcome, ma'am.
session.
Welcome.
It was great to have you here, sir.
Thank you, ma'am. Thank you so
Thank
much.
you so much. This is a token of appreciation for you, sir, on behalf.
Thank you, ma'am.
Thank you,
I'm
sir.
accepting.
Thank you. I also request the participants to, turn on their cameras for a quick snapshot, please.
I request you all.
Can you please request you to turn on your cameras, please? Okay, everyone. Thank you. Thank you so much. Stay safe. Take care.
Thank you, ma'am. Have a good day, ma'am. Thank you so
Thank you,
much.
everyone. Bye.
Bye. Bye.